In this video, let us discuss about the semiconductors and their classifications. Semiconductors are substances whose conductivity lies between the conductors and insulators. Some of the examples are silicon and germanium. Semiconductors have resistivity which is less than the insulators and more than the conductors. They have a negative temperature coefficient, that is, the resistors in semiconductor increases with the decrease in temperature and vice versa. An important property is that when a suitable metallic impurity is added to a semiconductor, the conducting property changes. At low temperature, a semiconductor behaves like an insulator. Classification of semiconductors. The semiconductors are classified mainly into two: intrinsic semiconductors and extrinsic semiconductor. The extrinsic semiconductors are further divided into p-type and n-type depending on the type of impurity added on it. Intrinsic semiconductors. A semiconductor that is in extremely pure form is called as intrinsic semiconductor. Examples are silicon and germanium. Both are tetravalent, that is, they have 4 valence electrons. Each atom creates a covalent bond with the electrons of the neighboring atoms. The outermost shell has valence electrons which are loosely attached to the nucleus. When such an atom is brought close to another atom, the valence electron of these atoms combine to form an electron pair. This bond is called as a covalent bond, but this is not very strong. At low temperature, no free electrons are available for conduction as all the valence electrons are strongly bonded to the nucleus. While at room temperature, the covalent bond breaks as the thermal energies are applied, hence set the electrons free and is available for conduction. As the covalent bond breaks, the free electrons wander randomly and these free electrons create a space called hole. The hole is considered as a unit positive charge while the electron is considered as a unit negative charge. When an external electric field is applied, the electron moves in the opposite direction to the applied field while the holes move in the direction of the applied fields. The number of holes is equal to the number of electrons. Doping. The process of adding impurities to the semiconductor materials is known as doping. The conduction capability of an intrinsic semiconductor can be increased by adding these types of impurities. The doped intrinsic semiconductor can be called as extrinsic semiconductor. The impurities added can be trivalent or pentavalent. In pentavalent impurities, the outermost orbit consists of 5 valence electrons and it donates 1 electron to the conduction band of the pure semiconductor atom. Hence, it is called as donor atom. Examples are phosphorus, arsenic, etc. While in trivalent impurities, the outermost orbit consists of 3 valence electrons and it accepts 1 electron from the semiconductor atom and hence it is called as acceptor atoms. The examples are boron, aluminum, etc. Extrinsic semiconductor. An impure semiconductor that is formed by doping a pure semiconductor is called as extrinsic semiconductor. Depending on the type of impurity added, the extrinsic semiconductors are further classified into two: N-type extrinsic semiconductor and P-type extrinsic semiconductor. N-type extrinsic semiconductor. When a small amount of pentavalent impurity is added to a pure semiconductor, it gives the N-type extrinsic semiconductor. The added impurity has 5 valence electrons. For example, if a phosphorus atom is added to a silicon atom, the 4 valence electrons get attached to the silicon atoms and 1 remains free as shown in the figure. All these free electrons constitute electron current. In an N-type extrinsic semiconductor, as the conduction takes place through electrons, the holes are the minority carriers while the electrons are the majority carriers. When an electric field is applied to this type of semiconductor, the free electrons travel towards a positive end. So it is called as negative or N-type conductivity. P-type extrinsic semiconductor. When a small amount of trivalent impurities is added to a pure semiconductor, it gives P-type extrinsic semiconductor. The added impurities has 3 valence electrons. For example, if a boron atom is added to a silicon atom, the 3 valence electrons get attached to the silicon atoms to form 3 covalent bonds, while 1 electron in silicon remains without forming any bond. As there is no electron in boron remaining to form a covalent bond, the space is considered as a hole as shown in the above figure. In p-type extrinsic semiconductor, as the conduction takes place through holes, the holes are the majority carriers while the electrons are the minority carriers. When an electric field is applied to this type of semiconductor, the hole travels towards the negative end, and hence it is called as p-type conductivity. Thank you for watching the video. For more details, please visit our website or mail to us.